VIP. Let's kick it.
Today's lesson is going to be about graphing radical functions. Okay, what you see right there, that's a radical function. Well, actually it would be if I had something like y equals the square root of x. Radicals involve square roots, cube roots. For the example, cube root of 8 is 2. Fourth roots, the fourth root of 16 is 2. Another example, the fourth root of 81 is 3, because 3 to the fourth power is 81. These are all radicals. This is a radical. 81 is my radicand. 16 is my radicand. 8 is my radicand. The cube root of 8 is my radical. So we're going to look at how to graph some very simple radicals. So the first one is y equals the square root of x. Well, let's just pick some x's. When x is 0, the square root of 0 is 0. So my first point is 0, 0. Now I'm going to pick another point, or another x coordinate, like 1. If x is 1, the square root of 1 is 1, so y equals 1. So I'm going to graph the point 1, 1. Now I could let x be equal to 2, but 2 is not a perfect square, so that's going to give me a messy number. So I'm going to go to the next perfect square, which is when x equals 4. When x equals 4, the square root of 4 is 2, so y equals 2. So I'll graph the point 4, 2. My next perfect square that would be nice to try would be 9. Square root of 9 is 3, so y equals 3. So I'll graph the point 9, 3. Now I'm kind of out of room, so I'm going to graph this little sideways parabola that keeps on going, and the y gets bigger and bigger. Notice I didn't pick any negatives for my x's because I can't take the square root of a negative number. That's impossible. So since all of the x's that I'm picking have to be positive numbers, now I happen to pick perfect squares, but there's all kind of x's in between that I'm also taking the square root of. I just didn't bother with it. So basically my domain is all the x's I can try. As long as x is greater than or equal to 0, we're good. Now my range will be all of the y coordinates. The y coordinates, if you look at every one of these points and think about the y coordinate, and remember this just is going to keep getting bigger and bigger, y is going to get bigger and bigger from 0. So the range is all y's that are greater than or equal to 0. So this next function, f of x equals the square root of x plus 2, would be the same as just y equals the square root of x plus 2. You know, just like when we did parabolas or quadratic functions and absolute value functions, this plus 2 right here is just going to increase the y coordinate of the f of x by 2. Therefore, it's going to raise everything up by 2. So all we really have to do is take the parent function, the basic square root of x, and move it all up by 2, and we'll get our graph. But that's a little bit sloppy, so we'll do it a little bit better. Okay? So I know that my starting point is going to be here, because when x is 0, the square root of 0 is 0 plus 2 is 2. So 0, 2 is my first point. My next perfect square is 1. Square root of 1 is 1, plus 2 is 3. So I'm going to have the point 1, 3. My next perfect square is 4. The square root of 4 is 2. 2 plus 2 is 4. So my point 4, 4. My next perfect square is 9. So that would give me a 5, 9, 5. And then my function graph will pretty much look like this, because not only is it those points, it's all the points in between. If we looked at the numbers, they're going to be messy, irrational numbers, but they're there. All right, my next function is y is equal to the square root of x plus 2. Notice the plus 2 is inside of the square root function. So just like when we did quadratic functions with parabolas and absolute value, since it's inside of the function, it's going to have a left-right shift. And this is going to shift it the opposite of what you would normally think Instead of plus 2 shifting it to the right, it's going to shift it to the left. We've explained that before with the other function. So basically, it's going to be just the parent function shifted to the left, and boom. But let's go ahead and do it a little bit more accurately. So this is going to be my first point, because when x is, well, we don't want x to be 0. We want this to be equal to 0. Well, how can that be equal to 0? When x is negative 2. Negative 2 plus 2 is 0. The square root of 0 is 0. So our first point is negative 2. Now we want this to be equal to our next perfect square, which is 1. How can this be equal to 1? When x is negative 1. So negative 1 plus 2 is 1. The square root of that is 1. So we got negative 1, 1. Now I want this to be equal to the next perfect square, 4. How can this be 4? When x is 2. And the square root of 4 is 2. So I'll graph our point 2, 2. Next thing would be for this to be equal to 9, our next perfect square. When x is 7, that will be 9, and the square root of 9 is 3. So we'll graph the point 7, 3. And now I can graph my function. And I always try to make sure that this looks like it continues to go up. I don't want it to look like it flattens out. Okay, we need to talk about the domain and range. It looks like all the x coordinates for the graph of this function starts at negative 2 and gets bigger and bigger. So x is greater than or equal to negative 2. And it looks like the range looks like all the y coordinates are pretty much starting at negative 2 and then getting bigger. Remember, this keeps getting bigger and bigger, so y gets bigger and bigger. So it's basically y is greater than or equal to 0. Okay, now we have f of x equals negative 2 times the square root of x. I wonder what kind of effect that's going to have. Is it going to shift it left or right or up or down? No, what it's actually going to do is it's going to spread the graph out a little bit, and I think because that's negative, it's going to flip it a little bit. But let's see. When x is 0, the square root of 0 is 0, times negative 2 is 0. Next perfect square. The square root of 1 is 1, times negative 2 is negative 2. Next would be 4. That'd be the square root of 4 is 2, times negative 2 is negative 4. Next perfect square is 9. That would give me a negative 6. So I'll graph 9, negative 6. And so my function's graph is going to look like this. And remember, it's not just these 4 points. It's all the little irrational numbers in between. Because when you take the square root of a non-perfect square, you get an irrational number, but it's in there somewhere. So let's talk about the domain. Well, since we're just taking the square root of x here, x can't be negative, so it has to be non-negative. And the range, the y-coordinates, look like it goes from 0 down, so the y-coordinate's going to have to be less than or equal to 0. Okay, this guy looks like it has 2 shifts. The minus 4 inside of the function is going to shift it 4 to the right, and the minus 3 outside is going to shift it 3 down. So our starting point is going to be at 4, negative 3. So when x is 4, 4 minus 4 is 0. The square root of 0 is 0. 0 minus 3 is negative 3. There's my point, 4, negative 3. Okay, next I want this to be equal to 1. Well, 5 minus 4 equals 1. The square root of 1 is 1. 1 minus 3 is negative 2. So I'm going to graph 5, negative 2. Next, I want this to be equal to 4. Well, 8 minus 4 is 4. So we can have the square root of 4 is 2. Minus 3 is negative 1. So we graph 8, negative 1. And the next thing I would want this to be equal to would be 9. Well, that would be 13. And that's going to be off my graph. So this is as far as I can go. And that's good enough. We know what the parent function looks like. My graph's going to look about like that. Well, the domain, it looks like the x's start at 4 and keep going. So x is greater than or equal to 4. The range, it looks like the y-coordinates go from negative 3, and they're going to keep going up and up and up. So y is greater than or equal to negative 3. Now this one looks different. F of x is equal to the cube root of x. Well, if you type this into your graphing calculator, you would see that the parent function for the cube root of x looks something like this. which is a little switch. Because it turns out you can take the cube root of a negative number. For example, the cube root of negative 27 is negative 3. Why? Because negative 3 cubed equals negative 27. The cube root of negative 8 equals negative 2. Why? Because negative 2 cubed is negative 8. You can take the cube root of a negative number. Okay, so let's see where this graph came from. It's pretty simple. Okay, what's the cube root of 0? 0. So 0, 0. Okay, what is the cube root of 1? 1. So it's 1, 1. Okay, my next perfect cube is 8. The cube root of 8 is 2, so I'm going to go with 8, 2. The next perfect cube is 27. It's not going to fit on this graph. If I had bigger graph paper, I would do it. But let's go to the other side. What's the cube root of negative 1? Negative 1. Negative 1 to the third power is negative 1. And then the cube root of negative 8 is negative 2. And so the graph of our function is going to look something like this. Remember, it keeps getting bigger. It keeps getting smaller. It's going to look basically like that. Okay, and it looks like the domain is all real numbers. Can't use those imaginary numbers, but it's all real numbers. And the y-coordinates, if you remember, it keeps getting smaller over here and bigger over here. The y-coordinates are going to be all real numbers, so we can write it like that, or we can write it twice. Okay, last one. This is probably just going to be the basic cube root function shifted, let's see, 5 to the right or 5 to the left. Well, it's counterintuitive. It's really going to be 5 to the right, and it's going to basically look like that and like that. Let's go ahead and do a few points. Okay, I want this to be equal to 0. How can this be equal to 0 when x is 5 and the cube root of 0 is 0? So 5, 0 is our first point. Then I want this to be the next perfect cube, which is 1. How can this be 1 when x is 6? So 6 minus 5 is 1. The cube root of 1 is 1. I want this to be the next perfect cube, which is 8. Well, 13 minus 5 is 8, and then the cube root of 8 is 2. Okay, so I'm going to go with, I'm going to pretend like the 13 is over here. So we're like 13, 2. Of course, I have to do the 6, 1. Okay, now we got to go the other route. I want this to be equal to negative 1, which is a perfect cube. Well, 4 minus 5 is negative 1. The cube root of negative 1 is negative 1. So 4, negative 1. I also want this to be equal to negative 8. Well, negative 3 would work. Negative 3 minus 5 is negative 8. And the cube root of negative 8 is negative 2. I got negative 3, negative 2. The next perfect cube would be negative 27, but that's not going to fit on here for me. So I'm just going to go ahead and do my graph as best as I can. Like this, and I'm just going to keep going off like this. Okay? Okay, and I believe my domain and range again are going to be all real numbers. When you have the cube root, just about anything works. All right, well, that is the end of this very simple lesson. There's a lot more stuff to do, but this is the basics of it. Enjoy.
Ice, ice, baby. All right, stop, collaborate, and listen. I sit back with my brand new invention.